right, I guess we're ready to get started. I was out in the hall a while ago and somebody said, hey Steve, you better get in there. They're getting ready to start your presentation. I said, how do you know? He said, I heard people clapping. I said, no, that's after I get done, they clap. God, he's finally done, you know, so. Right. I'm going to be talking to you today about how you can manage streaming content on your wireless network. But before I do, I want to tell you a story. In March of this year, I had Tom Smith come down from, and Tom came to Dallas and did the MikroTik Internetwork Engineer training with me and a group of students. Anyway, long story short, how many of you know Tom? Okay, good. I'm glad that he hasn't infiltrated the entire MikroTik population. Anyway, long story short, Tom is Irish, and so he likes to enjoy a pint of Guinness every now and then. And I had never tried Guinness before, and will never try it again. But anyway, long story short, I took a little sample of the Guinness, and I called it beer, and it's not, it's actually ale, I'm told. But I took a sample of the Guinness to my brother-in-law, who is a veterinarian, and I had him send it off to have it analyzed. And he called me up, he said, I've got some bad news for you. I said, what? He said, I just got a letter from the lab, and it says that your horse has diabetes. I'll let that sink in for a little while. Okay, so if you don't know me, my name's Discher. I'm from College Station, Texas. I'm the guy with the bad microphone here. Right here, hello. Where is it? There it is, okay. I'm not sure how to hold it at this point. I thought it was directional, but I don't know. I'm a graduate of Texas University, also the home of Heisman Trophy winner Johnny Manziel. Woo! Okay, yeah, enough of that already. I had enough the first game. I've been using MikroTik since 2004 when I started my first WISP, sold in 2011. I've also written the book RouterOS. Just got to hit it harder. And I'm also a MikroTik certified trainer, and I teach RouterOS classes. And I operate a wireless distribution company called ISP Supplies. So I'm going to talk to you today about managing streaming content on your network. So my question for you is, who needs this? Well, WISP need this for sure. Secondly, if you're operating any kind of a Wi-Fi venue for resorts or entertainment options, then you probably are dealing with streaming content on your network already. And finally, any other fixed wireless operator. So I want to make a couple of assumptions. First of all, you have to assume that users are going to stream content on your network. If you think they aren't, you're wrong, and it's probably become a problem for you. Just Netflix alone, I found out yesterday, has 33 million subscribers. So if even 0.1% of those are using your network at one point or another, they're streaming movies. I like this slide. Yeah, I travel a lot. This at a hotel one day. It said, plugging into free Wi-Fi during your stay. Free actually means $9.99 per hour for an incredibly annoying Wi-Fi experience. So you may have experienced the same thing at this hotel. So if you've been telling your customers or telling your customers to tell their customers that streaming content is not supported on our network, I have some good news for you here today. You won't have to do that too many more times. So we have to start with an official disclaimer, and that is that Steve Discher is not an attorney, and I do not play one on TV. Any legal advice that I will give is probably wrong, and you should question everything I say. If it sounds like a legal opinion, you should question it. I'm going to try this other one here. Hello, hello. Oh. All right, now. Hello.
So question everything that I tell you here today. Why do I say that? Well, in 2010, the FCC passed a ruling called net neutrality. And what they were trying to do is to keep evil, large cable and internet operators from offering a new voice over IP service that works great on their network, and suddenly Vonage doesn't work anymore. I wonder why. Well, this is supposed to keep people from doing naughty things to their customers. The first two I really don't believe have anything to do with what I'm proposing here today, because I'm not going to show you a way to block traffic. I'm not going to suggest to you that you don't have something on your terms of service that says you're doing this, but what I am going to show you may be termed as unreasonable discrimination, because it says that if you unreasonably discriminate in transmitting lawful network traffic over a customer's broadband internet service in an unreasonable way, where some websites appear slower or degraded in quality, and you may be breaking the net neutrality law. So check with your attorney before you try navigating through this gray area. Now, having said that, network operators like hotels, RV parks, and the like, I believe you can probably get by with shaping traffic however you want to, and you're not going to have an issue with that. On the other hand, fixed wireless operators like WISP should probably use some concern and get some advice before you start doing this. So I'm going to have the assumption today that you are trying to help your customer. You're not trying to slow down their streaming service so that you can sell them one that works better. I'm also going to make the assumption that the purpose of streaming traffic is so you can enhance their experience. And the methods that I'm showing you here today are obviously applicable to your entire network, but I'll kind of focus on what you would do at the CPE device to make the customer's experience better. So for example, if your customer is buying a 1 meg service from you and you prioritize their Netflix so that it can use their entire 1 meg, and then if they have 2 users, you distribute it accordingly, that you shouldn't have much of an issue. So how much bandwidth do we need for a streaming service like Netflix? It's just kind of been a day of issues here as far as things operating properly. Yeah, I'm going to move all these devices away.
Maybe
I'm starting not to trust you, Normus. So what is the solution? Well, the solution is to ensure that streaming traffic always has access to sufficient bandwidth, even if that means starving bandwidth from other types of traffic. So if we're watching a movie, we want to make sure we get the full, in this case, 512K stream of traffic. And if someone else is trying to browse the web, they only get traffic available to them when we're not actually downloading movie. So how's that done? Number one, we're going to identify the most popular sources of streaming traffic in the US, and I'm no expert on what people watch, but what I've mostly seen is YouTube, Hulu, and Netflix. Those kind of seem to be the big three. I'm sure there's others as well, but some of those may or may not be legal, so we won't try and help those out. The way we're going to do this is to create queues in RouterOS. We're going to sort our traffic using mangle rules and then usher that traffic into those queues and allow the streaming queue to fill before the other queues fill. So, sounds pretty simple. We're going to use two main facilities of RouterOS to do this, and they are the mangling facility, and we won't actually hurt any packets, so you PETA guys, you don't have to worry about this. And also we'll use queues and the queue tree. We'll also use some custom queue types as well. So, version 6, simple queues became much more powerful and much more resource friendly. So you're probably asking, can I do the same thing with simple queues? And the answer is yes. However, I want to make Giannis happy, and he likes the queue tree. So, and that's Giannis technical, not Giannis sales, for those of you that are familiar. And so we'll try and make him smile with the queue tree here today. So, quick start for the impatient. I'm going to show you how to set it up first, and then those of you that understand, if you want to leave, you can leave, that's fine, and then I'll go through the whys. Why mangling is done this way, why we're using regex, what regex means, those kinds of things. Now, here's a little teaser for you. If you do decide to stay to the end, I have a new product that we're going to show you that is made for MikroTik. No one else has it, it's brand new, just got the latest update from my developer about an hour ago. So I think it's pretty cool, and you might want to stay around and watch that. Of course, it'll be at the end, when the clapping starts. Okay, so I told you we're going to use two things. We're going to use queues, we're going to use mangles. So let's start with the mangles. Now, that's kind of fuzzy, isn't it? As far as the mangles are concerned, Netflix, for example, is going to look like regular HTTP traffic. So we can't do something as simple as look for TCP port 80. That doesn't work. We have to be a little more invasive into the packet and look into the packet using the layer 7 facility in RouterOS. So layer 7 uses something called regex, or regular expressions. And we'll talk more about how those are written later. But this is an example of a regex expression that I have found to be very good at seeing Netflix traffic. So the process is to go to IP firewall, layer 7, click the plus sign, create a new layer 7 matcher, I'll call it Netflix, and we paste the regular expression in there. The second step is to apply that regular expression to a mangle rule. So we're going to mangle in the forward chain. And if you remember from your MTCNA training, forward chain is going to see traffic that's going to our customers. Then on the Advanced tab, we select Layer 7 Protocol, and this is the Netflix matcher that we created over here. And then on the Action tab, we're going to do something called Mark Connection, and we're going to make the connection mark Netflix, or Netflix Connections. Okay? We'll leave the pass-through check for now. We'll uncheck that on the next rule. All right, so the first thing we do is we look for connections. The second thing we do is take a look at the connection tracking table at the connection mark Netflix-cons. And the action is mark those packets, and we'll mark them as stream and uncheck pass-through because we're done with those packets now. So we have a pair of mangles that are looking for Netflix. Now we need a pair of mangles that will look for everything else. All right, so this one is not very discriminate. It on the packet matcher, we're again in the forward chain, but now we're not selecting anything, which means it matches everything. And since this mangle is ordered after the Netflix mangle, this rule will catch everything else going through the router. The action is going to be, again, mark connections. This time we'll mark it as all other traffic connections, pass it through to the next rule, which then looks for that connection mark and marks the packets all other traffic. So now we have two types of traffic identified: Netflix traffic and then everything else. And this is what the mangle rules look like in the firewall mangle list. Next step is the queues. We're going to create a parent queue, a top-level queue we'll call all downloads. Now, we're concerned about how much traffic we're receiving, not how much traffic we're sending. So I'm only going to make one queue here for downloads for now. The parent is going to be the global HTB, which is new in version 6. No more global in, global out, global total, just global. Makes it a lot easier. What else? The max limit we'll set at 1 meg because that's what the customer is buying. That's his connection speed. Then we'll create 2 child queues. One for our streaming traffic, one for everything else. The only real difference between the 2 queues, they're both children of the all download parent queue, but the big difference is that this one has his priority set to 1 and his limit at setting. And if you remember limit at, it's a committed information rate. It's the amount of bandwidth that the parent will always try and supply to the child no matter what. So we've got him set at 1 meg. And we're using the PCQ type, PCQ download default. More on that later. Then a second queue we create for all other traffic. The priority we leave at the default of 8, and we set the max limit to 1 meg. This is the final configuration of each of these sections, so it's not that much to actually configure. Now, we threw in a simple queue here for customer upload because this guy is only buying the 512K upload speed. And in version 6, as Giannis will tell you shortly, simple queues have been moved after the queue tree. So you can do all of your QoS in the queue tree and then do your customer rate limiting in simple queues, and it makes it super simple. And for those of you that like to copy and paste, here you go. The slides will be posted in PDF form. You can copy and paste that in. There's some other items you obviously have to set up on your router, like DHCP, IP addresses, that type of thing, but I didn't include those here for clarity. All right, so time to dig in. All of you experts, you can leave now. The rest of you, we're going to work on this together. But if you hang around, you get to see my new toy. All right, so I like to teach the whys rather than just the how, because anybody can step through 1, 2, 3. But so we'll go through piece by piece and see what we're trying to accomplish here. First of all, the mangling. The purpose of the mangle facility is to identify traffic and then perform some mark on that traffic so we can identify that mark later and do something to it. So mangles typically identify traffic based upon source port, destination port, protocol, etc., or by using a layer 7 packet matcher, and that's what we are going to do today. So we identify it using layer 7, and then we mark it. These are the packet matchers which we find on the general tab of a new mangle rule. So we select the chain, pre-routing, forward, post-routing, whatever it is we're trying to accomplish, and we've already stepped through that setup there. The most important part on this slide, though, is the layer 7 protocol on the advanced tab. Let's talk about queues for a moment. Queues allow you to allocate bandwidth based on some criteria, in this case packet marks. So we can create hierarchical relationships between the queues so that some queues get bandwidth and other queues get starved for bandwidth. And that's what we're going to be doing here in a moment. Now, sometimes we call this traffic shaping, we call it traffic prioritization. It's important to know that when we say traffic prioritization, that can be a misnomer, and people think, oh, I understand, we're going to reorder the traffic, so when the streaming packets come in, we'll push those ahead of the other packets. Actually, not the way it works. With the HTB, what actually happens is that we make some queues more important than other queues, so they're allowed to fill first. So in this case, the streaming queue gets filled before the all other traffic queue. So the heart of this is the layer 7 matcher. And this is where you create it. It's under IP firewall layer 7 protocols. Click the plus sign and you create your matcher here. So remember layer 7 from the OSI model. It's like the nosebleed section. It's where we seldom go. You know, we do layer 1, layer 2, layer 3. Don't care about the rest of it, right? Well, layer 7 helps us out a lot here because in the 7-tiered model, this is where we can look at the packet, inspect the beginning portion of the packet, and determine what the traffic might actually be. Layer 7, we see the flavor of the traffic. So we can learn whether this is a file transfer, if it's an email, if it's Telnet, FTP, or in our case, if it's Netflix. The layer 7 matcher, what does it do? Well, it collects the first 10 packets of the connection for the first 2K, and then it searches for the pattern. If the pattern is found, it doesn't search any farther. And you do need to take into account that if you have a lot of throughput and a lot of connections, this can be fairly intensive. So what you want to do is make sure you have a beefy enough box to handle the connection, and also make your packet matchers as specific as possible so that you can reduce the amount of CPU load. An additional requirement with layer 7 is that it should see both directions of traffic, both incoming and outgoing, so we normally are going to place these in the forward chain. If we use the input or pre-routing chain, then we also have to use the output post-routing chain. That's straight off the wiki. I didn't make that up. So let's talk now about regex. Regex is like search expressions on steroids. So if I told you guys that started in the DOS days that I was going to search my directory for all files named star, you would know that that asterisk means anything. And then if I narrowed it down a little more and I said star.star or star.bak, now I'm being more specific. So that's kind of the way regex works, except it's much more powerful and has many more operators that it can use. So this presentation is not on regex. Why? Because I don't understand most of it, okay? Nor do I care to understand. Thank goodness Google is out there, and I can Google and I can rely on some friends to give me some regex expressions that they've stolen from someone else. But a little bit about it. The caret symbol matches the beginning of a string. The dot matches any character. The asterisk matches 0 or more of the preceding character. So dot star matches 1 or an unlimited number of any character. So with those main operators, you can do quite a bit. Regex has 7 different flavors, I believe, but the one used by RouterOS is found at the L7 filter project on sourceforge.net, and they have a fairly good explanation there. More sources of regex expressions. The wiki has a full page that you can download. It's actually in the format of a script file. And then on my site, mywisptraining.com, I have started a regex repository. So if you send me your regex expressions, I'll post them up there and share them with everyone else. I've got a whopping 3 expressions up there right now because I just did that last night. So after several beers, don't trust those expressions. My wife's listening to this, so I got to kind of tone it down. Okay, the mangle process that I described to you a while ago where we mark connections first and then packets, I like to call that the optimal mangle. Actually, I think I stole that. But the idea of the optimal mangle is that we match the packets, we pass them through to the next rule, and then we mark we mark the connections, pass them through, and then we mark the packets. That first sentence is wrong. Flip it. All right. Told you it was a rough night. No. This is the least resource intensive way to handle our traffic marking. And as the wiki says, we should match packets in the forward chain, and that way we get a look at both upload and download traffic. Why mark connections then packets? Again, it's the least resource intensive. It makes troubleshooting easier because when you mark the connections, now you can look at the IP firewall connection tracking table and you can see what your pattern matchers are matching. So I like it because it gives me some feedback there, makes me feel like I know what's going on. if you just match packets and mark the packets directly, it's difficult to see what you're actually accomplishing. The next step after we mangle is to create the queues. The queues are the basis of all of our quality of service, and in RouterOS they're based on something called the HTB or hierarchical token bucket. So the ability to prioritize those queues and let some fill up before others is what's going to make this work. In version 6, the queue tree was revamped, so we only have one global queue now called global. We don't have global in, global out, global total. It may seem like that hurts your granularity, but every queue tree that I've done so far, every setup, I've had little or no trouble translating that to version 6, and it works great. And it does make it a lot simpler. I like the hierarchical nature of the queue tree, so we're going to use that for our configuration today. Queue trees are most effective when we break them down into upload and download queues, and since streaming traffic is primarily download, we're just going to create the download for this particular setup. Note that we are using the PCQ queue type. Now, we've had PCQ queue type for a long time, but it's been changed a bit. In version 6, it is now NAT aware, so that's a good thing. Another thing is that if you look in the default queue types, there's now a PCQ download and PCQ upload default queue already created for you, so we can use those. The purpose of a PCQ, as you may or may not know, is to divide traffic into a number of streams based upon either source address or destination address. So when a PCQ looks at a flow of traffic, it can regulate each of those flows based upon who's actually doing the upload or who is doing the download. So with one queue, you can queue many customers. Remember, with the queue tree, the top level is the parent queue, and it's always going to try and satisfy its children's limit at setting first, and then if it has enough bandwidth, it will try and satisfy their max limit setting. So you can think of limit at as a committed rate, so you want to use that sparingly. In this case, we'll only set the limit at on the streaming queue. So we'll guarantee bandwidth to the streaming queue. All right, so how's this going to behave in real life? Well, let's assume that we have a 1 meg connection for our customer, and they have various types of traffic passing through it, HTTP, streaming traffic, FTP, and so on. All of that traffic goes into our router. If we have a queue set up with a 1 meg parent and 512K limits on the PC queue, then if 2 people are streaming at one time, if one person is streaming, they will get 512K. If other people are doing other things like an FTP, checking their news or looking at their email or whatever, they will all share the other 512 of traffic bandwidth that we have available. So in this scenario, the stream gets fed a full 512K, and then we have 512 left for everyone else to share for the rest of their traffic. If a second person starts streaming a Netflix movie, they each get a 512K stream, and then the queue tree will make best effort for any remaining bandwidth. So if you've ever noticed with Netflix, it tends to download, and sometimes it gets a little more downloaded than it is actually playing. So it stops downloading for a few seconds, then it starts downloading again. So anytime during those breaks, you're going to have extra traffic that you can give to other people that might be browsing the web or doing something that's non-streaming. How do you set the queues? What values do you put in there? Well, these are the 3 queues that we created. The first one is the all download queue. The second queue is what handles all other traffic, and this is the one that handles the streaming traffic. These are the names of the settings in the queue. You have max limit setting and a limit at setting. And this is how I would suggest, based upon the speed that the customer is buying from you and how many streams you can support, this is how you should set each of those queues. So this isn't rocket science, it's not hard and fast, but this gives you a general guideline of what you should expect to set. So what about limiting their upload rate since we only have a download parent queue? Well, as I said, the major change in version 6 is a packet flow diagram. In previous versions, simple queues were slower and they would rob bandwidth from the queue tree, but now simple queues are after the global HTTP. So, if you've never looked at the packet flow diagram before, you have to. I pushed it off as long as I could, and I finally had to embrace it and get comfortable with it. But as Giannis has told me time and time again, you have to be the packet, okay? Be the packet. Travel through, it's getting corny, sorry. You travel through the packet flow diagram and think about what's happening to the packet at the time. That way you put things in the right place. So, with simple queues moved after the queue tree global, we can do all of our download queues in the queue tree and then queue the customer's upload in the simple queue. So, it works out really well. What about upload rate limiting? Well, we said you can use a simple queue, which you can manually create yourself, but if your network is growing and getting larger, some other things you can do that will kind of automate it a bit. First of all, if you use PPPoE with a radius server, it can automatically send a simple queue to your router. It takes care of that for you, so you build the QoS tree and you let radius take care of supplying the simple queue. You can do it with a PPPoE profile locally on the PPPoE server, so that when the customer logs in with PPPoE, it automatically creates an upload queue for them. You can do it with hotspot user profile. So there's lots of ways to automate this, or you could just do it manually. So some suggestions. I tried to streamline this setup as much as possible so as not to confuse, and I'm sure someone could say, well, gosh, it would be less resource intensive if you did blah. I agree. I'm trying to keep it as simple as possible. So there's some things that you can do. You can make your packet matchers more selective. You can use a packet mark called no mark and a connection mark called no mark. If you're not familiar with those, MikroTik utilized the ability to actually put a mark on a packet or a connection that had never been marked before. And it's called no mark, and it's not visible in the connection tracking table, but it's there. So if you look at your packet matchers and you pull down on packet mark or connection mark, you'll see no mark there by default. That would be any connections that had not yet been marked. So that's another way to help identify and make this less resource intensive. All right, so if you were a glutton for punishment and you've sat around this long, I want to show you our new product that we're working on. We call this the RouterOS configurator, or the MikroTik configurator. And we created this because we get a lot of people that call us and they need help with QoS, or they need help setting up load balancing and that type of thing. This is not meant to cover every possible scenario, but it will create for you a generic QoS setup that you can put on any router very simply by just filling out this little form. So this is kind of like QuickSet. And QuickSet is getting more powerful and it's getting better with every version. But our particular RouterOS configurator, it is built on Java, so it'll run on Windows or on a PC. It has a container and plug-in architecture. So this container looks a lot like Winbox. Shocker, huh? And you buy plug-ins to go into the container. When you add the plug-in, the button becomes visible to you. You can click on the button and then produce some kind of configuration. This initial one will come with the QoS plugin by default, and then you can add other plugins later. Some of the others we're doing are load balancing, we're doing a firewall plugin, and so on. Again, this is not meant to be a one-size-fits-all approach. I have the configurator up and running, and I'll show it to you here real quick. Okay, so, oh, I don't have it over there. That's a problem. I swear somebody's controlling my computer. All right, there we go. All right, so this is the configurator running right now. The router that I'm going to apply this to, I'll go ahead and just delete the configuration from it so that we can see it happen in real time. There we go. Yeah, no, actually it's been very Very stable so far. That's what they always tell you, right? Problem is my contacts. I got to get some new ones. All right, there we go. Okay, so here's the configurator. The first thing you'll want to do is put in the administrative IP address of the router. The reason for that is what the tool is going to do is it's going to contact the router, it's going to log in, and it's going to pull the interfaces off the router so that we can use them in our configuration. So I'll click connect, I'll say a little prayer, I'll cross my fingers, and it says connected, so all is well. Now you'll notice the pull-down boxes have populated. This router only has 2 interfaces. So I'll set my WAN interface as Ethernet 1. I'll set my LAN as Ethernet 2. I need to tell it what my connection speed is. So I'll say that I have 10 megs upload and 20 megs download. Some other things that I can set here. First of all, this % guaranteed to higher priority traffic. The default here is 20%. We will probably massage that over time, but if you decide you want to allocate more or less bandwidth, you can do that as well. The first section is the per user rate limit section. So I can say John's network. For my comment, the user subnet, he's at 10.0.0.0/24. Max upload speed we'll give him a whopping 512K, and we'll give him 1 meg of download speed, and we'll add that in. If we want to add additional per user rate limits, we can do it there. These will just create simple queues for these customers. The next thing is the VoIP section. If your VoIP phones are marking traffic, the DSCP bit in some way, you could add that here. I'll just throw something in there for purposes of demonstration. Another one of these kind of generic rules that we're putting on the router is the IP address of all VoIP gateways. So if you have a PBX on your network and you want to specifically prioritize traffic to and from that PBX, you can put his IP address there. And then the last section is where there's a bit more power, and this is the services list. So down here, based upon the name of the service, which we put into the comment, the protocol and the port, we can set the priority. And as we continue to develop this, we'll supply new services lists that you can load in with the refresh service list button here. So at this point, and you can set, of course, the priorities here. So at this point, we have 2 options. One is we can click download script, and it will let us download the script. We can save it. We can use it on something else later. Or the one that I like that's more fun, and that is apply config. So it pops up and it tells you it's going to delete your existing rules. We say okay, and hopefully if all goes well, invalid trailing character. All right, so what we have, lowercase m. Do have to use the correct cases of our letters. Apparently I had my caps lock key off. All right, so I'll hit apply config, and it tells me the configuration has been applied, and I think in the background you saw some things pop up on that router. So now when we looked at the router, we have a queue tree configured, we have a simple queue created for John's network, and we have a series of IP firewall mangle rules created for us. So pretty simplistic. It doesn't fit all applications. It's not perfect, but it's pretty doggone good, and we'll have that available very soon. So if you're interested in our configurator tool, it will be available, and you can actually sign up at, where's it at here? MikroTikconfig.com. Please don't be critical of that website. It's horrible. I did it with the text editor last night. So anyway, MikroTikconfig.com. You can join the email notification list there, and as soon as it's ready for beta testing and for download, I'll select some beta testers, and then we'll actually have it available commercially. So that's all I have for you. Here's my website, so if you want to check me out. And do we have any questions out there? Yes, sir.
Where would you typically put the QoS on the route? Are you doing that at the tower? Are you doing that at the head end?
It really depends how your network is built, but my suggestion here for a provider network like yours is that you put it at the customer premise. That way it can be individual for that customer. That way you're not making global changes to all traffic passing through your network and possibly creating a problem for yourself. Now in a venue like a hotel, obviously you would want to be able to control QoS for the entire facility. So if you have a lot of devices connected together at layer 2, like a bridge configuration, then you would want to put it at the upstream router, the first upstream router. Anybody else? Man, you guys are going to let me out of here quick. Ah, darn. All right. Yeah. Yeah. The PCQ queues have a rate setting, and that is the amount of bandwidth per subscriber, if you will. So that's where you would set that. So if you wanted to make sure that everyone got 1 meg, you could do it there. Okay? Yes, sir. Yeah, but I was doing it on a single router with 2 streams going at one time. So as far as the CPE is concerned, I was doing it on a 750, and it was negligible for 1 layer 7 rule. That's why I'm suggesting that the CPE is the best place to put this, because you're not going to have to worry about streaming hundreds of megs of traffic through your router and having to handle all that. Anybody else? Yes, sir.
Is it possible to do this with a couple of simple queues? So we have our Netflix package for customers that automatically do the queuing, and the hotspot would configure that form?
I would think so. Yeah, that shouldn't. I don't think that would require too much work at all, especially if you're using the PCQ queue types. Okay. Yes, sir. Yeah, the container tool, we're thinking like maybe $99 for the container tool, and then selling the plugins, you know, depending upon how complex they are, you know, $25, $30, something like that per plugin. So we're going to make it economical. We're not trying to make a lot of money, just recover the development cost. You can use as many times as you want to. Yes, sir.
How do you find that good, that string which identified as a Netflix packet?
Okay, so the question was, how do you figure out how to write the regex expression? Is that generally what you're saying, so that you could apply this to other technologies as well? Yeah, you know, the number one way is to do a quick Google search, and a lot of times you'll find what you need. If you have to actually sit down and go through the tediousness of figuring it out for yourself, you're going to be having to use something like Wireshark and actually start looking at traffic streams. I found a pretty good tutorial on how to do that on that SourceForge layer L7 site, so I would start there. Yeah, it kind of shows step by step how to do it with Wireshark. Regex plus Hulu plus layer 7, something like that. Yeah. Yes, sir.
I'm going to go back to the CPE load. For some of us that are using products, we want a lot more than integrity and some other products in there. What kind of load can you expect? Otherwise, what kind of load are you expecting if we have to do it at the tower level?
If you only have, how many different types of streams are you trying to look for?
Everybody from Hulu, Netflix, you know, just the more common ones. Because we're using a kind of a self-homemade product now. Using a Linux server
Okay.
to do it, but that looks very interesting.
Okay, so I think restating the question, what the question is what kind of load could we expect if we were operating this closer to the core of our network where we're seeing a lot of traffic? I've only experimented with it, and I haven't found it to be terribly resource intensive. I was using it with an RB1100 with 3 different sets of mangle rules, and on the network at the time we were seeing about 70 megs of throughput, and I was probably seeing 35% CPU utilization. So I mean, it's more than not doing it, that's for sure, but really the only way you're going to know is to try it on your network and see how it works for you. And you know, you don't have to set up the queues and everything, just set up the mangles and see how much load the layer 7 inspection is doing. That way you're not breaking anything.
Where did your load start on that?
Where did what?
Where did the load start? In other words, you're saying that 3 megs.
If I remember right, it was around 20-25% is where we started, and adding 3 mangles at 70 megs was adding another 10 or 15, maybe 20% at the most. Yeah, and that's one of the reasons for using the 2-step mangling process, because we're not having to look at every single packet. We're not having to mark so many, you know, yeah, we're marking the connection first, then we only mark the packets that are a member of that connection. Yes, sir. Okay.
That's how we've gotten away from the 1100 to 40% CPU CCR. I haven't seen more than 4 or 5% utilization. I'm about a 250 meg connection roughly going through.
Okay. Anybody else? I don't want to take too much time. We've got other presentations. Yes, sir. Yes, MikroTik will put it up, and I'll put it on my site too. So, plenty of places to get it. Anybody else? All right, great. So thanks for your attention, and I hope you enjoy the MUM.